For each of the following equations, state whether it represents an ellipse or a hyperbola, find the center and lengths of the major and minor axes for an ellipse, or the center, vertices, and asymptotes for a hyperbola. All right, why don't we just quickly run through each of these and decide whether it's an ellipse or a hyperbola. Number one, I see x has cosine and y has sine. That's an ellipse. Number two, I see some things squared with a plus sign in between, also an ellipse. Number three, some things squared with a minus sign in between. That's a hyperbola. Number four. All right, so this equation we're going to have to do some work on to decide whether, or to get all the information that we need. But ultimately, there's an x squared plus a y squared, and I think that's going to make it an ellipse as well. We'll know more about that one after we complete the square. Number five, same kind of thing. This is an x squared minus a y squared. That's going to be a hyperbola. The directions for 6 are different, so we'll come to that later. And now let's see if we can find all the pertinent information for these other examples. So going back to number one, let's see, what we need to do is find the center and then the lengths of the major and minor axes. Okay, so the first thing I'm going to do is add a couple of numbers into my original equations. So the x equals 2 cosine, I'm going to write that as a 0 plus 2 cosine. And then the y equals 3 plus sine, I'm going to write that as 3 plus, what am I going to use here? Let's use green, 3 plus 1 times sine. And we'll see that those numbers are important as we answer these questions here. So the first thing I want is the center. So the center is just the 0 and the 3. I'm going to write the 0 in the same red that we used before. The 0 and the 3 are just how far you have to move from the origin to land at your starting point. And then once you're at the starting point, which is 0, 3 in this case, you'll go 2 cosine of t left and right, and then sine of t up and down. Okay, the major length, well, first we got to decide which one is longer. So the left and right motion is 2. You're going 2 left and right, and the up-down motion is 1. That's why I put the 1 in there. So the major one is the bigger one, which is 2 in this case. So that says that we're going 2 left and right from the center, and 1 up and down from the center. So that means that the major length is 4 because we're going 2 to the right and 2 to the left. So altogether we're going 4. And then the minor length, go up 1 and down 1, and altogether that means the minor length is 2. Okay, number 2. It's another ellipse, but it's written in a different form. So we need to find the center. We know the center is hk, and this is supposed to be x minus h. So the x-coordinate of the center is 8, except it's really negative 8 because of that minus sign built into the formula. And then the same idea, that's supposed to be a y minus k in there. K is 7. Remember, you got to change the signs when the equation is in this form. Okay, the major length. So we need to find the a and the b. And remember that a squared is that number. So that means that the a value is root 3, which means that you are going left and right root 3. And we'll look at the other one as well. This is your b squared. So that means that b is 2, and 2 is the up-down number. Okay, so the bigger number between root 3 and 2 is 2. We're going 2 up and down, which makes the major axis 4 altogether. 2 up and 2 down. And then the minor axis, you're going root 3 left and root 3 right. 2 root 3 is the length of the minor axis. Okay, number 3. Same format as the previous question. I'm going to put division by 1 here because I need to know what my a and my b are. So for this one, the center is the same idea as before. 1, -3, changing those signs. Forgot what we're supposed to find for hyperbola. Center, vertices, and asymptotes. Okay. So in order to find the vertices, let's again think about our left-right business and our up-down business. So a squared is 1, which means that a is 1, and that's your left-right number. And then looking at this guy, we see that b is also 1, and that's your up-down number, which means that you're going 1 unit left and right from the center and 1 unit up and down from the center. And that's going to give me 4 different points. I'm going to write them all, and then I'm going to cross 2 of them off. So let's go 1 left and right from the center. The center is 1, -3. Go 1 to the left, that's at 0, -3. 1 to the right is at 2, -3. Now let's take care of this green stuff up here. 1 up and down from the same center. Go 1 up, and that lands you at 1, -2. Go 1 down, and that lands you at 1, -4. If it helps you to plot these points or plot the first point to help you, then by all means do so. Okay, but really it doesn't hit all 4 of these points. We need to figure out exactly which ones it hits. So because the x squared is a positive and the y squared is the negative, see the order here, I think we decided that that meant that this was a left-right hyperbola. And one little quick trick that I can maybe share with you that helps me remember which way it is. Suppose that we were to simplify the equation, just make it the same equation but centered at the origin instead of at 1, -3. Then if you wanted to find the x-intercepts, then what you do is let y equal 0. And so if we temporarily let y equal 0, then this term drops out and you get x squared is 1. And so x is plus or minus 1. And that's fine. And then when you find the y-intercepts, you let x equal 0. And this term drops out. And now you're solving negative y squared equals 1. Well, that has imaginary solutions, not real solutions. So there are no y-intercepts. So I'm imagining a graph where it hits the x-axis at 1 and the y-axis at -1, but it never, hits the x-axis at 1 and -1, but never hits the y-axis. And I got to draw a hyperbola that hits these 2 points. Well, pretty clearly, if I'm not allowed to hit the y-axis, it looks like that. So that's how I remember real quick that if the x squared is the positive 1, then it's a left-right. Okay, so it's a left-right hyperbola, which means that the points that we found by going left and right from the center, which were these 2, are the actual vertices, and I'll just put a line through the other 2. Okay, in order to find the asymptotes, the equations of the asymptotes, we got to do something that we didn't do in class. So one thing that you might do is, if you haven't done so already, is plot your 4 points, draw your rectangle that goes through those 4 points, and then see if you can find the equations of the asymptotes. So pause the video and come back after you've done that. Okay, so hopefully you've got 2 equations. There's some work involved in finding the 2 asymptotes. It's not hard, but it's a process. But it turns out you can do this process without actually graphing everything. So here's what I'll say. The slope is always equal to the b value divided by the a value with the plus or minus in between. So in our example, the a value and the b value are both 1. So that means the slope of our 2 asymptotes are positive 1 and negative 1. And we know definitively that the center is on both of the asymptotes. On -3 is definitely on both lines. So now it's just a matter of writing down equations of lines that have a slope of 1 and hits the point 1, -3, and the same thing, slope of -1 and hits the point at 1, -3. So how about we use the y minus y1 version? The only thing that changed there was the slope. Okay, number 4, this one's going to involve quite a bit more work because we have to complete the square. Additionally, this is the harder version of completing the square because the coefficients of x squared and y squared are not 1. So let's do a couple of steps in 1 here. I'm going to imagine grouping in the front the x terms and grouping at the end the y terms. And now I'm going to factor the 36 out of the x terms. So 36 comes in the front, x squared minus, let's see, does 36 go into 108 3 times? I'll leave a little space, plus the, oops, a little space there, plus, then we're going to factor the 8 out of the y terms. 8 into 16 is 2. Leave a little space there. And then we'll move the 17 over to the other side. Okay, so I think we're so far so good. And now we got to add the magic number in the parentheses. So we're taking b over 2 and we're squaring it and we're sticking it right there. Okay, so b is -3 in this case. -3/2 squared is 9/4. And then the same idea in here, but now b is 1. B is 2. B over 2 is then 2 over 2, which is 1. Squared is 1. But now we got to balance the scales here by adding those things to the right-hand side. But we got to be really careful because those are numbers that are in disguise. So we know that this 9/4 is going to get multiplied by 36. So we didn't really add 9/4. We really added 36 times 9/4. I think that's 81 if we multiply together. So then we'll add 81 to the right-hand side because we added it to the left-hand side. And then the 1 in the parentheses is really an 8 in disguise. So we're going to add 8 as well. Okay, next step is to factor. And it's always going to be x plus b over 2 squared. So that -3/2 is in there, plus 8. This one you don't really need a formula, it's just y plus 1 squared equals, what do we get over here? 89, 79, 72. Okay, standard form for the equation for the ellipse and the hyperbola have equals 1. So we need to divide everything by 72. This guy right here dictates what we need to do. So both sides get divided by 72. I'm splitting that 72 up because we have a big plus sign in the middle here. And then I can reduce separately. So that's going to go in twice. That's going to go in 9 times. So when all is said and done, we finally get the good version of this equation. That's over 2 plus this guy over 9. And now it's equal to 1. So now we can look at this and read off the information we need. So the center, +3/2, comma, -1. Major axis goes with the bigger number, which is 9. That means that the b value is 3, because that's b squared that you're looking at. Double 3 is 6. That's the length of the major axis. Minor axis, we're looking at a squared equals 2. So a is the square root of 2. That's how far you go left and right. So the length of the minor axis is double that, 2 square root 2. Okay, this one is the same idea. We need to do lots of work before we can identify all the pertinent information. So we're going to group the x squared terms, the x terms first, and factor out the 4. 4 goes into 24 6 times. Leave a space. Minus, that's the minus sign that's circled. Then we're going to just write the y terms here, but we got to factor that minus sign out. So that plus 4y changes. It's really easy to miss that. Changes to a minus 4y. And move the 36 over. The reason that we're factoring the negative out is because we need it to look essentially like, x minus something squared and then minus some other stuff squared. So that minus sign has to come out. Even though this guy doesn't really have a minus sign in it, we force it. Okay, add the magic numbers. 6 over 2 is 3, squared is 9. Negative 4 over 2 is negative 2, squared is 4. This 4 times 9 is 36. That minus 1 times 4 is negative 4. So for the first time, we actually ended up subtracting something on the left-hand side. Okay, so we said we added 36. So we'll add 36 here, and we subtracted 4. So we're doing the same thing on the left as we did on the right. Or I should have said that the other way. Do the same thing on the right that we did on the left. Write these guys in factored form. Okay, just like the last equation, we need it to equal 1 when all is said and done. So let's divide everything by negative 4. And we'll go ahead and split that up. Okay, so this becomes 4, negative 4. So this guy becomes x plus 3 squared over negative 1 minus y minus 2 squared over negative 4 equals 1. So that is standard form, but it's not looking so great, actually. These negatives are going to cancel. And this negative we're going to put up in the front here. We got to decide, is this a left-right hyperbola or up-down? My initial reaction was that it was going to be a left-right because the x squared is the positive one. But when we actually went through the calculation, if we rewrite this, we'll see that the x squared is actually negative. So this becomes y minus 2 squared over positive 4, canceling that sign and that sign. And then putting this sign here in the middle, minus x plus 3 squared over a positive 1 now, because I've moved that minus sign from here over to there. So this is actually an up-down hyperbola. But now we can pick off all the relevant information. So the center, looking in the parentheses, is, got to be really careful. It's tempting to say 2, negative 3, but that's not right. We got to look at the x guy first, negative 3, comma 2. Okay, we needed some vertices. All right, so let's, instead of writing all 4, let's just write the 2 that are called the vertices. This is an up-down hyperbola, which means we got to decide how far to go up and down from the center. And whatever we land on will be the vertices. So this says you're supposed to go up and down 2, left and right 1, but that part doesn't matter to us. So we're just going up and down 2 from the center. So up 2 from the center, negative 3, 4. Down 2 from the center, negative 3, 0. I'll put in parentheses up and down 2 from the center. And it's a 2 because square root of 4 is 2. Okay, and then finally the equations of the asymptotes, I'll put them up here. Okay, so what do we need here? I guess I'm going to start with my slopes, plus or minus. So it's the b divided by the a. The b we've already found is 2, that's this guy. And the a, well, it's 1 because this is a squared. A squared is 1, so a is also 1. So it's plus or minus b over a, plus or minus 2 over 1. So the slopes are just plus or minus 2. And we needed to hit the center. And the center is negative 3, 2. So we just have to write our 2 equations. So y minus 2 equals 2x minus negative 3. And then the same thing, but a negative slope. And you can clean this up and solve for y if you're so inclined. I'll leave it like that. Okay, finally 6 is just a little bit different. It's not asking the same. We don't have to do all that stuff for number 6. Graph the equation xy equals 1 and to rewrite it as an explicit equation. So that means solving for y. We get y equals 1 over x. Does it appear to be a conic section and what type? So let's go ahead and graph this on the calculator. although y equals 1 over x was in our toolkit of functions, I think, from the very first part of this course. But it isn't one that we really talk about very much. Standard axes, probably fine. That's not looking to be very good. So how about we try like -3 to 3? Okay, that looks a little bit better. So what kind, does it appear to be a conic section? And if so, what type? It appears to be a hyperbola, but in a different way. It's not a left-right hyperbola or an up-down hyperbola. It's just oriented differently. So I guess we can say it's oriented at an angle instead of being our standard up-down or left-right.